All right, so one way to think of propositional logic, and I think a pretty useful way to think of it, is it's almost like its own different language, right? You know, we will talk about translating from propositional logic to English. Well, what we're doing there, we're translating from one language to another, right? So I think that's a useful way to think of it, right? As a different language than English. And look, every language has its own grammar, right? If you've taken a foreign language, you know this is true. You know some of them are very different than English, right? The only foreign language I really know well is German, besides, but you can do stuff in German, the grammar there that you can't do in English, right? Most one that's most striking to me, darn near anything can go at the beginning of a sentence. So, get these weird statements. Anyway, that's neither here nor there. My point just is propositional logic has its own grammar. Thank God it's not as complicated as English grammar, and goodness, if you've ever taken German, thank goodness it's not as complicated as German grammar, which is, to my mind, even more complicated than English grammar. I'm sure Germans would disagree and say that our language is harder, but whatever, right? Propositional logic's grammar is pretty simple. There aren't a lot of rules, but you have to follow it, or the strings of symbols you're going to have will just be nonsense. Right? Yoda, if you've seen the Star Wars movies, can talk in really ungrammatical English and we understand him. Strings of symbols in symbolic logic that don't follow its grammar are going to be pretty much nonsense. You really won't be able to understand them, right? So a little bit of jargon. Strings of symbols that stick to propositional logic's grammar are called well-formed formulas, WFF. Strings that don't aren't. So what are these rules? So look, the symbols for conjunction are little ampersand, disjunction are little v, and there's two others, the conditional and biconditional, which we haven't talked about, but we will. Conditional is a little arrow pointing one way, biconditional is an arrow pointing two ways. All of these symbols must go between letters or blocks of letters. And anytime you have more than one letter in symbolic logic and propositional logic, you have to have one of these between the two letters. One letter makes sense on its own. Two letters just pop together do not. Negation is the weird one, right? Negation always has to come before letters or blocks of letters. It cannot come before other symbols, and it cannot be between blocks of letters on its own. Look, these two slides have all the rules, the really basic rules for symbolic logic. It's really important that you learn these and follow them, but they're not hard. I had a student a few semesters ago who just refused to get this. He would put the symbols in the weirdest places. Can't do that, right? A or B, A and B, and not A are all well-formed formulas. They all follow the grammar of propositional or symbolic logic. And A or B, or A, B, A not B are not well-formed formulas. These are not grammatical. Look, in the same way we can understand Yoda, even though his grammar is atrocious, in some cases we could probably puzzle out what the person probably means by this, right? Or AB probably means A or B, right? That if I had to guess, A not B probably means A and not B. But the point here is, this is really vague, right? You're having to guess at what the person means, and you can probably be about 60 or 70% there. But the whole point of symbolic logic, or a lot of the point, is to be precise and avoid vagueness and ambiguity. If you're having to guess at what the other person means, you aren't doing that, right? When you have to interpret what the other person says, we have to do that with ordinary language, with English or German, or I don't know the language, but I'm sure Chinese is the same way. Took French and forgot all the French I took. Mais non, right? But no, I still remember that. But most of the French I forgot, but I remember French being that way too. But symbolic logic, propositional logic, the whole point is we don't want it to be vague or imprecise in the way that other languages are, or at least a lot of the point. And when we have to interpret what the other person says, when they give us ungrammatical or badly formed formulas, we lose that. So this is important. Learn these rules, follow them. Otherwise, you'll end up speaking gibberish at worst, and at best, making the other person guess what you mean. Final thing I'll say about the grammar of propositional logic, and this is super important, is that parentheses are super important. How do we treat parentheses? Well, you treat them in the same way you do in math, right? Everything inside parentheses you do first. What this means is, if it's inside parentheses, treat it as one block. See how this works in real life, right? A, not A, and B means something entirely different than not A and B. Not A and B, well, you read the A, the not A first, and then the B, right? You read the symbol between them. Not A and B, you read the A and B first, and then you look back to your little not symbol. If A and B is true, the not's false, because you treat everything inside the parentheses as one block. If A and B is false, then the little not is true, right? What does this mean in practice? A and B means that A is false and B is true. Not A and B means A and B are not both true. Let's make this less abstract, right? Let me give you guys an example. Let's fill in what our little symbols. A equals Abe will go to the party. B equals Bob will go to the party. All right, so now that we've filled these in, what do these two statements mean? Not A and B means Abe won't go to the party, but Bob will. Not A and B, it's hard to say the difference out loud, right? But not parentheses A and B parentheses equals Abe and Bob won't both go to the party, right? And again, I think it's always, and this is one of the reasons I'm a little steamed at Lavin for not introducing this earlier, I think to see the difference, it's always helpful to go back to the truth tables, right? Well, look, these two statements have different truth values, right? Not A and B is only true when A's false and B is true, right? When Abe doesn't go to the party and Bob does. There's only one line where it's true. But there's two lines on this truth table where not parentheses A and B parentheses is true when the first one's not. If Abe goes and Bob doesn't, well, it's true that they didn't both go, right? If neither of them go to the party, then it's true that they didn't both go, right? So statements mean really different things. So especially when you start bringing in negation, our little tilde not symbol, parentheses are going to be super important. They're also important whenever you have more than two letters. Like take this. A and B or C is vague. It could mean A and B or C, or it could mean A and B or C. Add another little one here, right? We have Abe will go to the party, Bob will go to the party, we'll add a C, Claire will go to the party, right? Well, A and B or C means either Bob and Abe will both go to the party, both of these guys will go, or Claire will, right? And this statement would be true if Claire went to the party and neither of these guys went. It would be true if they both went and she didn't go, right? A and B or C means Abe will go to the party and either Bob or Claire will also go. Means something different, obviously, in English, right? And it's true in different cases, right? If Abe doesn't go but Claire does, this first sentence will be true. But anytime Abe doesn't go to the party, the second sentence will be false, right? All right, so hopefully starts to make a bit more sense to you guys. We will practice a lot more with this. Just the lesson here is parentheses are super important, especially with negation or when you start to get more complex sentences with more than one letter. Be careful with them.